Hi, in this video we're going to go through a number of examples of molecules made up of covalent bonds. So the first of the molecules that we're going to have a look at is HCl. HCl, hydrochloric acid. So HCl has two different atoms, hydrogen and chlorine. It's probably worth knowing where these lie in the periodic table just to work out what their electronic structure would be like. So this question actually asks us to draw an electron shell configuration diagram as well as an electron dot diagram. Now the electron shell configuration diagrams require for us to show all the electron shells, whereas the electron dot diagram only requires for us to show the valence electrons. So the electron dot diagram is going to be much simpler. So hydrogen as an element has one electron in its outer shell. If we go to the periodic table, we will see that there is that hydrogen is element number 1, meaning it should only have one electron, thereby only really being able to have one electron in its only shell. Let's draw that circle a little bit better. Okay, so here's hydrogen. Chlorine is in group 17. So group 17 means that chlorine will have 7 electrons in its outermost shell. It's also in it's in period 3, which means that it would have 3 electron shells. Okay, so in its first shell there'll be 2 electrons. Second shell we have 8 electrons, up to a total of 10. And then in the third shell we will have 7 electrons for a total of 17, and that matches chlorine's atomic number, which is 17. Okay, so as you might have seen in the previous video, covalent bonding involves the sharing of electrons, and the sharing occurs between unpaired electrons. So here are the unpaired electrons right here. They will come together to form a covalent bond. So what would this look like? So hydrogen here will have shared its outer shell with chlorine's outer shell. So let's draw all of chlorine shells. If you see now, hydrogen has 2 electrons in its valence shell, 2 electrons in valence shell, which is actually a full shell for that first shell, which can only hold 2 electrons at maximum. So hydrogen has a full outer shell, and chlorine has an octet. So it has 8 electrons, an octet in its valence shell. So chlorine's happy now. So this covalent bond here, circled in red, has enabled both elements to obtain full outer shells. Now to draw the electron dot diagram is much simpler than drawing the electron shell configuration diagrams. This is what the electron dot diagram would look like. And in terms of the valence electrons here, we can see that they're identical. These diagrams are identical. So if we look at these outermost shells, chlorine has 8 electrons in its outermost shell. Once it forms its bond with hydrogen, we can see that here all the same. Alright, so for the next 2 examples, we'll only need to draw electron dot diagrams for the compounds. Okay, so here we have two different elements, 3 atoms in total. So there's 2 hydrogen atoms, 1 sulfur atom. Now sulfur, where do we find sulfur in the periodic table? Sulfur is in group 16, and by the classical numbering system, it's in group 6, meaning it has 6 electrons in its outermost shell. So let's draw an atom of sulfur. 1, 2, 3, 4, 5, 6. And that's the electron dot diagram for an atom of sulfur. Hydrogen, no, it looks like this. So there are 2 hydrogens. So if we're going to look at the bonds that are formed, here they are. What's this going to look like now? So sulfur, sulfur, and the 2 hydrogens with the pairs of electrons. What do we have here? So sulfur now has obtained an octet, a full outer shell of electrons, as we can probably see here. So if we count the total number of electrons, we have 1, 2, 3, 4, 5, 6, 7, 8. So sulfur clearly has a full outer shell. Each hydrogen atom has 2 electrons, which means it has a full, both atoms of hydrogen have a full shell as well, a full first shell. So you can see our covalent bonds have enabled all the atoms to obtain octets once again, or full outer shells once again. Now the last example involves phosphorus and chlorine. Now phosphorus, P, and chlorine, Cl. Now we know chlorine is in group 17, which means it has 7 electrons in its outermost shell. What about phosphorus? Well, if we look on the periodic table, phosphorus is in group 15, or in the classical numbering system, it's in group 5, meaning that it will have 5 electrons in its outermost shell. So let's draw that. 1, 2, 3, 4, 5. Okay, so there are 3 chlorine atoms, because the superscript 3 in front of the chlorine tells us there are 3. So let's draw in 3 chlorine atoms. Alright, now where are the bonds going to be formed? So we look for the unpaired electrons on all the atoms. These are where the bonds will be formed. So unpaired electrons will pair with each other, and the result is hopefully a molecule where all the atoms involved have full outer shells. So like I have with the previous examples, for your sake I have color-coded different atoms so you can observe the origins of these electrons. So you can see phosphorus has 5 electrons here. In this final molecule we can see that 5 of these electrons originate from phosphorus. 5 of the electrons that surround phosphorus originate from phosphorus, but 3 extra electrons have surrounded phosphorus, but these have each come from a single chlorine atom. So does each atom have an octet? Well, if we were to look at every single individual atom, we would find that each one can claim that it has an octet. Each atom has 8 electrons in its valence shell. So this covalent bonding has enabled the formation of octets, and this is what we see with covalent bonding and ionic bonding. Atoms coming together to either share or transfer electrons, and the end result is that the atoms will have full outer shells. And this is really the aim of the bonds that are formed, the aim of the atoms. Okay, well, hope this helped. Thanks for watching.